One of the coolest things that I run in my home lab is Pterodactyl, a completely free game server platform for hosting different dedicated game servers like Minecraft, Rust, Valheim, and so much more. In fact, I actually run my Foundry virtual tabletop on it as well. In this video, I'm going to walk you through getting it installed on some dedicated hardware and getting it set up. So let's get to it. This video is brought to you by HomeLab Gear. My home lab was a mess, so I designed and created a variety of different products to help me manage and protect all of my sensitive gear, and they're available to you too. Tackle the storage of your countless 3.5-inch mechanical drives, organize all of your random 2.5-inch consumer and expensive enterprise SSDs, protect all of your delicate NVMe SSDs, store all of your DDR DIMMs and those easy-to-misplace SODIMMs, and collect and protect all of your expensive SFP transceivers. You can get all of these and more right now too. Just head over to homelabgear.shop or check for a link in the description and get your home lab organized. Hey there, home labbers, self-hosters, IT pros, and engineers. Rich here. Let me tell you a story. I'm not only a tech professional by day and home labber by night, I am also a dad with 2 young teenage kids who, like me, love playing video games. In the past, when they would ask me if I could spin up a game server for something like Minecraft or 7 Days to Die, I'd have to spend time researching, learning, and then deploying either a container or a VM manually to get that game server online. Depending on the complexity of the server, mods, and so on, that could take sometimes up to a couple hours from start to finish. And then they'd maybe play for 30 minutes, maybe a few days at most, and never touch the server again. As a dad and a home labber, I want to provide them the services that they want, but the effort over the payout just wasn't there. And then I found the Pterodactyl project.
Pterodactyl is a free, open-source platform that simplifies the process of hosting and managing game servers. It provides an intuitive web-based interface allowing users to easily set up and control servers for popular games like Minecraft, Rust, and more. By utilizing Docker containers, Pterodactyl ensures that each game server operates in a secure and isolated environment, enhancing both performance and security. The big benefit for me using Pterodactyl is that once it's set up, my kids can create and destroy their own game servers as they want. I don't have to do anything.
One of my favorite things about Pterodactyl is the diversity of different servers and services that you can host on it. For example, I am a D&D nerd, which should come as a surprise to no one, and I'm currently running a campaign for my friends. I use Foundry Virtual Tabletop to facilitate that game, and I use Pterodactyl to host it. You can also host voice chat servers if you're not a Discord person. Basically, anything you can run in a container, you can manage through Pterodactyl as long as you have an egg to create it. We'll get more into eggs here in a second, but first, let's talk about how I'm going to deploy.
This is the HP ProDesk 400 G5 mini desktop PC that I picked up for $80 locally. It is the perfect platform to be a dedicated, self-hosted Pterodactyl server. It's running a 9th Gen Intel Core i5-9500T CPU that features 6 cores, 6 threads, a base clock of 2.2 GHz, and a boost clock of 3.7 GHz. It's also rocking 16 gigs of DDR4 memory and came with a 256GB NVMe that we'll swap out for a 1TB drive to buy us some extra space.
You can get these little ProDesk units on eBay for roughly the same price. We'll toss a link in the description if you want to follow along and build something similar. Also, just in case you're wondering, you can absolutely run Pterodactyl in a virtual machine. I'm just using this little unit here to showcase how you can buy something like this or similar small form factor desktop and leverage its low power efficiency to save money on electricity, but also have a really powerful and robust self-hosted game server. All right, I'm going to walk you through the installation process of Pterodactyl, get it set up and running, show you how to build your first game server, import eggs for games that aren't already on the platform, talk about any gotchas along the way, and then we'll talk about how you might make this available to the internet to allow your friends to play with you. Let's get to it.
First things first, I want to upgrade the NVMe SSD in this unit. The ProDesk is a really nice, simple little system that makes upgrading the NVMe super quick and easy. All we need to do is remove the retaining screw from the board, slip in the replacement NVMe, in this case I'm using an older 1TB Samsung NVMe that I had lying around, replace the screw, and then close up the box. Done.
Let's talk about operating systems first. Pterodactyl is meant to run and install on Linux, and specifically, Pterodactyl supports Ubuntu and Debian, and Red Hat, Rocky, and Alma Linux. I am an Ubuntu guy, so I'll be choosing Ubuntu Server 2404 for the install on this little HP ProDesk. I'm going to be using Ubuntu Server specifically because I don't want the overhead that running a GUI brings. But you could absolutely install Ubuntu Desktop on this as well. Just know that it'll take a little bit away from the available system resources. Before we install Ubuntu on this unit and get Pterodactyl installed, let's talk about a few different paths or directions that you can take this and some basic network configuration stuff that you're gonna need to do. Pterodactyl is designed to allow you to make it directly accessible on the internet so that people can log into the panel, choose a game server, configure it as they'd like, and then deploy it. Putting on my security hat, I'm going to tell you that if you intend to make more than just your hosted game servers accessible to the internet, you need to take precautions as to how you have that server connected to your network and how you protect or isolate it from the rest of your home network in case of compromise. This decision is solely yours to make, and I can't be responsible for poor planning or deployment practices. My plan in this video is to show you how to deploy Pterodactyl internally on your network, making the panel and administration only available inside of your network, and then at the end we can discuss poking holes to make only your game servers available externally for people to connect to. If you're interested in a deep dive into configuring Pterodactyl to be a hosting service, then let me know in the comments. With that out of the way, before we install Ubuntu on our Pro Desk, we need to make sure we have two things ready for our host. First thing you're going to need is an internal IP address, and you're going to need to create an internal DNS record to resolve your host name. Pterodactyl really likes to do things via host names over IP addresses, so to make all this work, you're going to need to create an A record for your host to resolve its internal IP address to its host name. Okay, let's kick off this install.
I won't bore you with the installation of Ubuntu server. There's nothing special about my install. Just install Ubuntu as you would normally, with the exception of configuring either a DHCP reservation or a static IP address for the host, installing SSH server, and that's it. Once you've got Ubuntu installed, we'll move on to the next step. The first thing I like to do when working with a fresh installation before doing anything else is to make sure the system is fully patched and up to date. I use the command apt-update, --apt dist upgrade-y, --apt auto-remove-y, --apt auto-clean-y, --reboot, and hit enter. This single string of commands will update apt, upgrade any out-of-date packages and kernels, clean up after itself, and reboot the system.
Pterodactyl is technically comprised of two different components. The panel, which is what provides GUI management for creating and managing game servers, users and access, and configuration, and the second component is known as Wings. Wings is the system that deploys, runs, and controls the Docker containers that host your individual game servers and other apps you deploy. Panel is the management GUI, Wings is the orchestrator for Docker. Cool? Pterodactyl's website provides you step-by-step instructions on how to install it, but I'm going to be honest with you, it's a lot of manual steps and it's not very user-friendly. In fact, when I began working on this video, I started down the path of building out an install script myself. Then I came to my senses and started looking for someone who'd likely already solved this problem and honestly would do a better job than I could ever do, and I was right.
Over on GitHub, I came across this project made by Wilhelm Pritz, who brilliantly automated the entire setup of Pterodactyl Panel and Wings, the platform that manages and deploys Docker containers for game servers. We're going to be using his script for the initial configuration, setup, and installation of the Pterodactyl Panel and Wings. Let's get to it. Once your system is back up and online, get logged in and use the command sudo-i to become root, as the next steps require us to be root to execute it. Now enter in this command below and press enter. This script is like a Swiss Army knife for Pterodactyl, and with it you can deploy however best fits your setup. Option number 2 is what we're looking for here because we want to run both the panel and Wings on the same system. As an aside, if you want to build out Pterodactyl as two different systems with the panel on one system and Wings on another, you can easily do that with this script as well. We'll select option 2 and move on. First up is to define the database name for the database that serves the panel. You can get creative here, or you can just go with the defaults by hitting enter, which is what we're going to do. Next, we need to define the database username. Again, we're going to go with the defaults because there really is no need to make it custom. Now we need to provide a password for the user previously generated. You can enter in a password or just hit enter and have it generate a random password. That's totally your choice. I'm just going to hit enter. Next up is to define your time zone for your server. I'm on the west coast of the US, so I'll be using America/Los Angeles. If you don't know the entry for your time zone, refer to the URL listed above to find the correct syntax for your time zone. Alright, let's talk about SSL encryption. This script will configure your host to pull valid SSL certs from Let's Encrypt, which is particularly useful if your panel is internet-facing. I don't plan on using Pterodactyl with SSL because the scope of this video is for the system to be available only inside my LAN, but we'll enter in an email address anyway, even though a bit later we'll be choosing not to enable Let's Encrypt. Now we're going to create the first user for Pterodactyl, who will also have administrator rights. Pterodactyl wants your email address because you can configure the platform to send emails when alerts occur. I'm going to use the same email address I just entered previously. Now we need to provide the username we want for our first user, followed by the first name and last name, and a password for the account. Alright, if you remember earlier in the video, I mentioned that you should have a static IP address and a DNS record to resolve your Pterodactyl server inside your network. Here's where you enter that hostname. I went with tero.tracelink.home, which is my internal-only domain. Obviously, yours will be different. The script will also configure firewall settings to help better protect your system. If you're exposing Pterodactyl directly to the internet, I would recommend you say yes to this option. However, since I'm running this as an internal service, I'll say no. Back to Let's Encrypt. If you are exposing Pterodactyl to the internet and you would like to use Let's Encrypt for valid SSL certs, here's where you'd start that process. Again, because this is internally hosted for me, I'm going to say no here. And again, because I'm not using SSL certs, I'm going to say no to configuring Nginx to use certificates. Alright, we now see the summary of the configurations we've selected. The script will now build out our Pterodactyl panel. Let's hit yes and let this cook. This process will take some time to complete, and the time it takes will depend on your hardware and your internet connection speed. Just be patient and let the process finish. My install of panel took roughly 1.5 minutes to complete. Now on to the next step. Now that we've successfully installed Pterodactyl panel, we need to install Wings, the Docker manager and orchestration component of Pterodactyl, so we'll hit Y and hit enter to kick that off. The first question we're asked is if we wish to configure the firewall for Wings as well. Again, this is internal only, so we'll say no. Next, we're asked if we want the script to create a user for database hosts automatically. We'll say yes and hit enter. This system will be deploying MySQL for database activities, and we can make MySQL accessible outside the host. This can be a security risk, and we don't need that functionality anyway, so we'll say no and hit enter. Okay, now we can define the database host username. Feel free to create something unique or just accept the default, which is what we're going to do. Now we need to create a password. Choose something memorable and hit enter. Okay, another question about Let's Encrypt. Again, this is internal, so we'll say no and hit enter. Alright, it's time to kick off the install, so we'll say yes and hit enter to get Wings installed. The script will install Docker, MySQL, and configure everything for the next step. Alright, now we're nearly done with the base configuration. Leave your command window open here because we'll need it again shortly. Our next step is to head over to the Pterodactyl panel and get some configurations made. Alright, now open your browser of choice and head over to the URL you set up for your Pterodactyl host. Again, I set mine up as tero.tracelink.home. Yours is going to be different. Welcome to the Pterodactyl login screen. Enter in your username and password that you set up in the first half of the script. You can log in with either the username or the email address you provided during the setup. Alright, the default dashboard we're dropped into is the servers dashboard, which is completely empty because we haven't created any servers yet. But before we can do that, we need to add our Wings installation, known as a node, to our panel. So we'll head up to the cogwheels on the top right. This is the administrative overview for Pterodactyl. Think of it as the backend for management and configurations for your Pterodactyl installation. Before we create our node, we need to create a location for our node. So we'll head over and click Locations on the left. Nodes need to be added to locations, which is why we need to create the location first. Over on the top right is the Create New button. We'll click that to start defining our new location. Remember, a lot of what you see here in terms of functionality in Pterodactyl is designed to allow you to create your own externally facing game hosting platform, so what you decide to call your location should reflect your deployment intentions. This is only for inside my network, so I'm going to call this location Home and click Create. Alright, location defined, let's add our Wings node now. Over on the left, click Nodes. Again, nothing's here yet, so we'll head over to Create New on the top right and build out our node. Okay, we need to define a few things for this new node. First things first, we need to give our node a name. Since this node is also on the same host as the panel, I'm going to name it Tero. Next, we need to provide the hostname or IP address to connect to the node. We'll enter in the hostname for the host, and then because we didn't configure SSL for the node, under Communicate over SSL, we'll select Use HTTP Connection. Now, over on the right, we need to define the limits for the node. First off is memory. I know my host has 16 gigs of RAM on it, and because this host is dedicated to hosting only game servers, I'm comfortable with giving it most of the RAM on the host, leaving a bit of overhead free for the underlying OS itself. So I'll enter in 15,000, giving me a bit of overhead for the rest of the system. In terms of memory over allocation, because I'm giving basically everything to my game server, I'm not going to provide any over allocation, so I'll set that to 0%. Now on to disk space. I know my host has roughly 1 terabyte of storage space total, but again, giving it all to the game server would be a bad idea. So I'll enter in 800,000 and again set the disk over allocation to 0%. All done. Now we'll hit Create Node. Okay, now we need to configure Wings with our configured node parameters, so we'll head up to Configuration at the top. Now, instead of manually copying and pasting the configuration file in the console of our host, we'll use the Auto Deploy feature on the far right. So we'll swing over and click Generate Token on the right. All we need to do is copy the line of code in the middle there, pop back over to the SSH session we still have running, drop in the copied token, and hit Enter. Boom! Wings is configured. The last thing we need to do here now is start Wings, and to do that, we'll type in systemctl start Wings and hit Enter. Perfect, we're done with the console now, so you can close it if you'd like. Back to our browser and the Pterodactyl panel, and click OK to the token window, and we'll head to Nodes again on the left to make sure our connection is healthy and functional. A green heart means we're good to go. There's one more step for the configuration of the node, and that's allocations. Alright, we'll head back into the node configuration by clicking on its name in the list, and then we'll head up to Allocations at the top. Allocations are basically network port configurations that you explicitly define for any game servers you host to run on. When you define allocations for a node, they'll be automatically provided down to the game server when you configure it. Our node doesn't have any allocations defined as of yet because it's brand new, so we'll configure them now on the right. The first thing we need to do is define the IP address for the node hosting the ports. We're just going to use the existing IP address that's assigned to our node, so we'll enter in its IP address now. You can also define an alias for the address if you'd like. Next up is to define the list of ports you want to have allocated to that IP address for hosting. We can enter up to 1,000 ports at a time, so we'll use 40,000 to 40,999 and click Submit to add the allocation. Now we see all of the port allocations on the left with the IP address we defined for the system. Congrats, Pterodactyl panel and Wings is fully set up. Let's talk about what's next.
Okay, now that we have the basic setup for Pterodactyl, let's talk about eggs. An egg is basically a complete install script that encapsulates everything Pterodactyl needs to download, configure, and host a dedicated game server for a specific game. By default, Pterodactyl comes with a few eggs already preloaded on the platform, like Minecraft, Rust, and a few source engine-based games. Before I show you how to download and add eggs to your new Pterodactyl install though, let's first start by deploying a preloaded egg for Minecraft.
Alright, let's run through deploying a game server on Pterodactyl. Back to the Administrative Overview dashboard. On the left, we'll click on Servers. This is going to be our first server, so this page is blank, but here's where you'd see other servers if you had them deployed. Over on the far right, we'll click Create New to get started. First stop is to give our server a name. This is the name of the instance, not the in-game name of the server. I'll call this server Rich's Minecraft Server. The next stop is to assign the owner of the server. This deployment only has myself as a user, but if you create other users, you could assign them ownership of the server. The system will autofill as you type in the owner name. On to allocation management. Here's where you could choose a node if we had multiple nodes. I only have the one we just built, and it's automatically selected by default. Under default allocation, we can see all of the ports we've allocated to be used for servers, and if you wanted to, you could choose a specific port. By default, Pterodactyl will just grab the first available port in the list. Additional allocations allows you to add additional ports as needed for whatever you're hosting. For example, if you had a game server that also had an integrated VoIP server for in-game chat, you could define additional allocations for whatever additional ports were needed. For Minecraft, by default, we only need one port, so we'll just leave this blank. In application feature limits, you can define how many databases, allocations, and backups a user can create for this server. 0 in Pterodactyl essentially means unlimited, and typically the defaults are fine here, but if you are hosting for others, setting limitations here can significantly protect your system's resource usage and stability. Alright, in resource management, you can define the limits that this particular game server can consume. We'll run through this quickly. CPU limit allows you to set limits on the total amount of CPU resources available on the host. If I'm being honest, I leave my server set to 0 and just keep an eye on them. CPU pinning allows you to pin your server to specific threads. Just leave this blank, guys. This isn't VMware. Memory is next. Here's where you define the total amount of memory available to your game server. Again, 0 is unlimited and you can totally use that. However, I'm going to tell you this. I've never been burned on CPU contention, but I have on RAM contention, so I always define my allocated RAM, and for this server, I'm going to give it 4 GB of RAM. Next is disk space. You can either define a set amount of storage space for your game server, or again, leave it at 0. I have had issues with some servers requiring you to define a set amount of disk space, and some that don't care. I'll give my Minecraft server a gig of storage space. I typically leave swap and block IO weight as is and have never had a problem with those settings. But in the case of swap, you may need to provide swap space to certain containers if they need it, so be aware. Also, there's an option to enable OOM killer, which will terminate a container if it overruns its memory limits. But as it says, it can cause system instability, so I never enable it. Alright, nest configuration is next. Here's where you define the game server that you want to run. Nests are collections of eggs, and again, eggs are the configurations for a specific game server. Pterodactyl comes with a few preloaded Minecraft eggs. So think of a nest as a collection of eggs or games, eggs, nest. You get it, right? Anyway, we want a Minecraft server, so we'll stay with the Minecraft nest, and now we'll want to choose which version of Minecraft we want to deploy by selecting the appropriate egg under the egg dropdown. All of these versions of Minecraft listed here are different deployments of Minecraft, some with mods, and vanilla Minecraft being just that, the vanilla version. On the right-hand side, we can choose which version of Java we want to deploy in the container. And vanilla Minecraft runs just fine with Java 21, but other mods might require a different version, so your mileage may vary. In terms of customizations, below you'd find any additional customizations as needed if they're supported for the game server you're deploying. Vanilla Minecraft is basically ready, set, go, so we'll leave the rest of the settings as is and click Create Server. And with that, Pterodactyl is deploying our dedicated Minecraft server. We can check on the progress of the deployment by heading up to the top right and exiting the administration panel, and then we can click on the newly created server and access the running console of the container. We also get stats on the CPU, memory, and network usage of the container, as well as options to start, stop, and restart the container as needed. Since this is the first deploy, we have to accept the EULA for Minecraft, which pops up. Once we accept, we can watch the Docker container complete its deployment and mark itself as running. All we need to do now is point our Minecraft client at the IP and port listed, and away we go.
Let's talk about eggs more in depth now, specifically how to find them for your favorite games and how to import them so you can spin them up and start playing. On the Pterodactyl website, they actually link to an egg repository site that you can use to search for and download eggs for whatever game or service you're wanting to spin up.
This is the Pterodactyl Egg site that links from the Pterodactyl site directly. Its simple design allows you to throw in a game title and search to see if there are already available eggs for you to use. For example, we can search for Valheim, and we can see there are 3 different eggs available, a vanilla version and a few modded versions as well. We can click on any of these to see more details, and then click download to grab the JSON file.
That website is an easy way to search if you know what you want to find, but you can't use wildcards to display everything in the repo. And sometimes you just want to see what's out there and available that you might want to be able to spin up. And the good news is you can by visiting the GitHub repo behind the scenes. Let's go there now.
This is the actual GitHub repo that hosts all of the eggs that the previous site searches. Personally, I like this method better because I can see everything that's available, get some inspiration, and maybe try out some things that I wouldn't have otherwise thought of. It's a lot of fun just to browse through all of the different eggs available.
So let's load in a downloaded egg so you can see how easy it is to do.
Back to the administrative dashboard of Pterodactyl, our first stop is nests at the bottom. Again, remember, nests are collections of eggs, and Pterodactyl comes with a few out of the box, like Minecraft, a few source engine-based games, voice servers, and Rust. The game we're going to add is Valheim, which we downloaded the egg for just a bit ago. Thing is, Valheim really doesn't belong in any of these nests, so I'm going to create a new nest. Over on the right, we'll click Create New to create a new nest. You can choose to name your nests anything you'd like that best fits what they'll hold. Valheim server is built on top of Steam CMD, so I think that's the perfect way to categorize this nest. And then we'll hit Save to finish the nest. Alright, here we are inside our newly created nest, and as you can see under Nest Eggs, we don't have anything here yet. To import our egg, we'll actually need to head back out to the top level Nests section. So we'll swing over and click Nests again on the left. Now back on the top level, head over to Import Egg on the right. All we need to do now is select the Valheim JSON egg I downloaded, and then select which nest to store that egg in, and click Import. That's it.
Now let's quickly talk about networking and making your games available to people on the internet. There are a lot of ways you can go about making Pterodactyl available to the outside world, and a lot of how you go about this really depends on your knowledge, your physical network and firewall, and honestly, your level of acceptable risk. For me, the only thing I'm presenting externally are the game servers themselves, and I'm doing that through port throughs on my pfSense firewall. I also have my Pterodactyl server in my DMZ separated from the rest of my internal network, and only internal traffic can access the management GUI directly. I know people who either make make Pterodactyl directly accessible to the internet or nest the management interface behind a Cloudflare tunnel. And again, that all comes down to your network, your knowledge, and what you consider acceptable risk. I don't feel comfortable making the PHP Web GUI available to the outside world, regardless of it being behind Cloudflare or not. I just rather Pterodactyl be managed and controlled from the inside, but the game servers themselves, well, they're contained in Docker containers and I can easily blow them away and rebuild them as needed. I'm fine with that level of risk. As an aside, let me know in the comments if you'd like a video focused on network security around Pterodactyl or even general networking, and we'll see what we can do. Or you can always join our Discord and ask your questions there. So let's wrap this up and talk about my final thoughts. Anytime I can find a system or tool that actually solves a real need in my life, I am all about it, and Pterodactyl does that for me. There is such a wealth of available eggs for practically any game that you can host a server for. I'm using it for my Foundry virtual tabletop to run my Pathfinder 2e campaign right now, and it is doing such a fantastic job. Not to mention that now my kids are spinning up their own servers and managing everything without having to wait for me. It's literally a win-win. I do want to point out that the script I used really makes Pterodactyl accessible to everyone. Without having that script, following through the documentation, which, complete and helpful, is very much targeted at people with deeper knowledge of HomeLabbing and not really user-friendly. Lastly, I want to know what you think. Tell me in the comments if you're using Pterodactyl or something else, how you connect to the internet or don't. I would love to know. And that, friends, will do it for this video. If you liked it, throw us a sub and a like, and if you have a beef with anything I've said here, let me know in the comments below. Special thank you to YouTube members. You guys help keep the lights on, and we thank you for it. If you want to help support the channel, consider becoming a member or buy some of our swag. It all helps us keep making these videos. And now that you finished watching this video, how about checking out this playlist over here of great HomeLab videos we've done in the past? If you're looking for your next great HomeLab idea, we can help.